For today's notes, you will need in-class 69. This is part 1 of standard 16, where we will be learning about volume of 3D solids. So the solids we'll focus on today are both right prisms and cylinders. So first things first, volume is going to be the space that is inside a geometric solid. That's different than surface area, which is where we just came from. Surface area is the collected area of all of the outer surfaces of a shape. Now we're thinking about how much can actually fit inside that three-dimensional shape. For both prisms and cylinders, we're going to find our volume by doing capital B times capital H. So what ends up happening is that capital H still represents the height of the geometric solid. That's going to be the distance between the two bases. Capital B still represents the area of the base of the geometric solid. And so what we do is we find the area of the base. So in the case of a cylinder, for example, it would be the area of a circle. So imagine all of that has been calculated. And then we stack that up along the height. And what ends up happening if we stack all of those circles up, one on top of the other, over and over and over and over again, is that base area, once it's multiplied by the height, ends up filling up the entire cylinder, and that gives us the volume. So it's kind of like a sleeve of Ritz crackers, the area of one Ritz cracker, and then you stack a bunch of other Ritz crackers on top, and pretty soon you filled up that entire sleeve. Okay, so as a reminder as well, to find that capital B, we're going to use the formulas that we previously studied. So if our base happens to be rectangular, we're going to take that lowercase b and lowercase h and multiply them together to find that area. If our base is triangular, we will still need a lowercase base and height, but depending on whether that triangle has a right angle or not, sometimes that means we'll be using sides of the triangle, but other times, remember, that means we might need a height that's on the interior of the shape, and then the base will still be a side of the triangle. For our regular polygons, no matter how many sides they have, we're going to use AP over 2 to find the area of the base. Remember that apothem goes from the center of the shape to the midpoint of a side, and then the perimeter is that distance all the way around that solid. Perimeter can be found by doing the number of sides times the side length, n times s. And then last but not least, if our base is a circle, we'll use our pi r squared formula, where r is that distance from the center of the circle to the edge. All right, let's go ahead and jump in to find some volumes. We're going to continue paying attention to the name of the shape to be able to identify the base correctly. So this tells us that we're dealing with a prism and that we're dealing with a base that's a square. So that must be the bottom of the shape since I see 3 inches on both of the sides there. We still do have 2 bases in every single prism, just like we did with surface area. And our capital H, that height that we're looking for, is going to be the distance in between those 2 bases. So when we're thinking volume of a prism, capital B and capital H are the 2 things we need. We already have that capital H tracked down, so all that's left is to find the area of the base, which is going to be a quick 3 times 3 calculation, or 9. Volume then will be the base area of 9 times the height of the prism, which is 5. So now we have 45 cubed inches, because what we're doing with volume is we're filling up that whole entire space. So it's like we're stacking a whole bunch of little cubes in there, 45 of them specifically in the case of this square prism. Moving on to number 2, we can see we're dealing with a triangular prism. So our volume formula will still be capital B times capital H, but our base this time will be the triangular faces of the solid, which look like the bottom and the top again. I do notice up here we have a right angle and a side of 10 across from that. I'm going to pull this 8-inch side up to the top so that that's in the same location as all the other information about the base. In between the bases, I'm seeing a capital H height of 7. So all that's left to do is to find the area of that base using our triangle formula. However, in this case, I'm noticing that this right angle is going to indicate to me to use these two sides as my lowercase b and h, and one of them is missing. So if I call 8 the lowercase b, then that means I need to find this lowercase h using one of our old standards. And it looks to me, with the help of that 10, which can act as c squared equals a squared plus b squared will be the best way to do that. The hypotenuse is 10. The side I know is 8. I'm looking for that lowercase h, so I'm going to go ahead and plug that in. If we do some squaring, we'll end up with 164, which then needs to be subtracted to isolate the h squared. And then last step there would be to square root and to come out with 6 equal to that h. So now that we've done that, we have what we need to fill in our lowercase b and our lowercase h, which gives us our base area of 48 divided by 2, or 24. Take that back to our volume formula. 24 for base area, 7 for the distance between those bases. Do a quick 24 times 7 calculation, and volume will be 168 cubed inches.